Okay, so for this problem, we have another crane with a 30 kip counterweight, and we are asked to solve for the forces on the front and back supports to our crane. All right, so just like last time, we're going to define our positive x direction and positive y direction, and define that counterclockwise rotation is going to be positive. So that's all of our given. So we're trying to find the force on the front support and the force on the back support. So again, this is a static equilibrium problem. Same process. Sum of the forces in the x direction is equal to 0. There are no x direction forces, so that's not super helpful. So next up, sum of the forces in the y direction is equal to 0. So just moving that left to right, we have a negative 8 kip force. We have a positive force on the front support. We have a negative 20 kip force. We have a positive force on the back support, and then we have a negative 30 kip force from the counterweight. So if we look at that, we have two unknowns and one equation, so that's not enough to solve the problem. So we have to do a sum of the moments equation. All right, so we've already defined a direction of positive rotation. So the next thing we need to do is define the center point for our moments. So we have two unknown variables. So the best method to do this is to choose the position of one of the unknowns as the point that we're going to sum moments around. So I'm going to choose the point of the front outrigger as my center point. So looking at that, the 8 kip force will cause everything to rotate counterclockwise. 20 kip force will be clockwise. The back support will be counterclockwise, and the 30 kip force will be clockwise. And then also we need to go ahead and we need to add to our given the distances given by the problem. 40 feet there, 2 feet there, 8 feet, and 4 feet. So our 8 kip force is counterclockwise. So I can go ahead and write that's going to be a positive moment. The 20 kip force is clockwise, so that's going to be a negative moment. The back support is counterclockwise, so that's going to be a positive moment. And then the 30 kip force is clockwise, so that's going to be a negative moment. And if I go ahead and kind of want to just track for myself what all my distances are going to be, the 8 kip force is 40 feet away from the front support. The 20 kip force is 2 feet away. The back support is 10 feet away. And then the 30 kip force is 2 plus 8 plus 4 is 14 feet away. So now that I've got kind of all that annotated, I can go ahead and put it together for my moment equation. So for the 8 kip force, I have a positive moment of 40 feet times 8 kips. For the front support, that's my 0 feet times the force of the front. So 0 times anything is 0. So then I have a negative moment for the 20 kip force, that's 2 feet away. For the back support, I have a positive moment that's 10 feet away. F back. And then for the 30 kip force, it's a negative moment at 14 feet away. Okay, and so at that point, I have an equation with a single unknown. The only unknown is the force on the back support because the force on the front support was multiplied by 0. So I can go ahead and solve through for all those numbers, and you get the force on the back support is equal to 14 kips. Go ahead and plug that into your previous equation. You get negative 8 kips plus 14 kips minus 20 kips plus the force on, oops, I substituted that in wrong. you get minus 8 kips plus the force on the front support minus 20 kips plus 14 kips minus 30 kips equals 0. Solve through on that, and you get that the force on the front outrigger is equal to 44 kips. Right, so notice the power of choosing one of your unknown variables to be the center point for your moment equation. It makes it so you don't have to do any solving and substitution. So again, I recommend trying to do that whenever you can on problems. However, as was shown in the previous example, you will still get the right answer even if you do not choose that method.